Okay. Yeah. So if we want a definition of 1 joule, how to define 1 joule? When we can say this is 1 joule?
I didn't get you.
When can I say there is a work done of 1 joule? How can I say that there is a work done of 1 joule?
When there's 10 parts on the.
No. I'm not talking about I'm talking about this. How to define 1 joule?
Oh,
What's 1 joule? How to define this? When I can say there is a work done of 1 joule? See the conversion here. Newton we can see here, and 1 meter. So force of 1 Newton displaced a body 1 meter.
of 1 meter. Yeah.
That's it. That is 1 joule. A force of 1 Newton displaced body by 1 meter. That is 1 joule. We can say 1 joule of work is done when force of 1 Newton. Right. So you know conversion of 1 Newton also, right? How to split 1 Newton? 1 meter per second square into 1 kilogram.
All
this conversion you know, right?
Yeah.
Okay.
MA.
Exactly. So this what we saw here, it is absolute unit. So if I make a short here, absolute unit of work. Absolute unit of work in SI is joules, in CGS is erg. These are absolute unit.
Yeah.
No, there are some more units. There is gravitational unit. What's the gravitational unit of work? Grams per centimeter. See, I'll show you here. Work is gram. Let me write short form. G cm. Gram centimeter. That is CGS. And kilogram meter. That is SI.
SI.
So how do we got this here? 1 gram centimeter, we can say 1 gram weight. That is 1 gram weight into 1 centimeter, which is 980 times into 1 centimeter, which is 980 erg. Now in kilogram, 1 kilogram meter is said to be 1 kilogram weight into 1 meter equals to 9.8 Newton into meter, which is 9.8 joules. Is this new for you?
Kind of, sir.
Okay, that's why you all are silent.
Yeah, the erg part is new for me.
These two are gravitational unit.
Yes, sir.
And dimensional formula. What dimensional formula? I think so. You know, right?
Yeah.
What is the dimensional formula for work?
ML0T. Let me think. I think so.
So if you can't remember, just make the formula.
MLT0.
ml square t power minus 2.
T cannot be 0. See, force into
Yeah,
displacement.
sir. Yeah. So ml square t power
Displacement
minus.
is L. Force, even if you don't know force, we know mass into acceleration.
Yeah.
So mass is capital M, acceleration is meter per second square. So let's combine all this. So meter
ml square.
M
ML.
to
Yeah.
ml2
T
power t power
minus
minus 2.
So break it. If you don't know, it's not wrong. If you don't know, just break it inside. Like F is MA. A is 1 meter per second square. So second means T. T minus 2. L T minus 2. Mass is M. Displacement is L. So this one plus this one, it will give you 2. So M L2 T minus 2. Okay. I think so this is clear, right?
Yeah.
Now, can we say work can be positive, or I can say work can be negative? So when can we say there is a negative work done?
When work is done outside the surrounding.
Outside surrounding?
Work is done in the system, then
So
it
like
will be positive.
negative is like force and displacement are opposite.
Yeah, they're in opposite direction. So which
Yes, sir.
force will be in opposite direction?
Net force is net
No, generally we have friction force in opposite
force.
direction.
Yeah, friction.
Right? Yeah, always keep it basic. So friction force, if we have friction force more, then we can say there is a negative work done.
Yeah, because force will be less. I mean, friction is more. Yeah, it's going opposite direction.
Exactly. So there is a case, suppose if I'm pushing the wall, okay, and this friction is more than my applied force. There is no displacement also. But I can say friction force is more, so it is a negative work done, but why there is a work done 0? So pushing, you understood what I'm asking? If I'm pushing the wall, we are saying that work done is 0. But that wall is having more friction force, friction of static friction more than our applied force. That's why wall is steady.
It won't
Okay.
move.
Yeah, so I can say work is negative, or either I should say work done is 0.
I would say work 0, sir.
It's a work 0. Why can't we negative work done that time? Because friction force is more.
It's
that
not.
time.
There's no displacement, sir. So displacement will be 0.
Okay, yeah. So either of them is negative or something is positive. Like there's only cases like work done is negative when either F is positive and S is negative, or F is negative and S is positive. Either of these cases. Let's see those. Like suppose if I go with the work done. What's formula? W equals to F cos theta S. When theta is 0. So what will happen?
Theta 0, it will become 1.
Yeah.
No, that's a 0 only. Cos 0 is 0 only.
Theta equals 0.
No, it is 1. Sorry.
Yes. So
Yeah,
work
1, sir.
done equals to force into displacement. So they both are in same direction. Force and displacement are in same direction. That means positive work done.
Yeah.
Now, if I take this way, if theta is 90 degree, then work done is
0.
0. Again, if I take theta as 180 degree,
Negative.
so work done, force into cos 180, which is minus Fs.
Yeah.
So I can say they both are in opposite direction,
Yes, sir.
right? Force and displacement are in opposite direction. Therefore, negative work done. Yeah. Anything else we missed? Cos 90, 0. Yeah, correct only. So here work done is 0.
That's it, sir.
That means force and displacement are exactly perpendicular. This 90 degree means perpendicular.
Yeah, perpendicular.
Force and displacement. Okay. So let's talk some example. Let's write some example. Positive work. So one example, we can say free falling object. Force is acting towards the Earth gravity. And so force is also acting towards Earth gravity and motion is also on Earth gravity.
Yeah.
So work done by the gravity is positive. So free falling body. Force acting downward due to
Gravity.
gravity, and the direction of force is also downward. So work done is positive. Second
So
one.
pushing a light object,
Yeah,
like
exactly.
light in weight object.
Exactly. What about spring?
Like spring means in where side, which spring?
Any spring,
Any spring, right?
like generally like spring, if we are pulling it. So is it positive work done or negative work done? Think.
It will go back to zero. Zero?
No, forget going back. I'm just pulling it.
Okay.
That's it.
Okay.
So I'm stretching it. That's it. I'm not like compressing it. I'm just stretching it. So force applied and displacement are in same direction. Think. You understand what I'm saying? Stretching a spring. Or stretch spring.
You mean suspend a spring?
Yeah. Is it force and displacement is same direction? Force applied and displacement, they both are in same direction or opposite direction?
Opposite.
How can it be opposite? Think again. And how can it be same? There is a thing again. See, hold one side of spring and just applied force from the other hand. Hold like one side of spring on the left hand and with right hand just pull it. So which direction you're pulling?
Both the directions.
No, not both directions. See, hold
Same
this.
direction.
So this is a spring. Hold this side and from this side pull it. So which side you will pull? This
Right
direction.
side. Yeah.
Right side. Right. Now which direction is the motion? That is also on right side. We are pulling this side. That means spring is on right side only. So force and direction of motion or displacement is on same side. Are you able to imagine what I'm saying?
Yes, sir. Again.
Okay. So this, like for your 11th standard, whatever you're studying, you can see and like feel it and imagine and you can understand. But when it comes 12th standard, everything is electron. You cannot see, you cannot feel it. So for that, you need to have very good imagination.
Yes, I imagine it correctly.
See, these things we can see. Spring, if you can't understand right now, still you can't just hold a spring and pull it. That practically you can understand.
I get it. I get it. I done
No,
so many times.
I'm giving examples. I'm just telling you like that. So if something we can't understand, we can just make it a practical for 11th standard, but 12th standard we cannot. Everything based on electron, proton, neutron. Where we'll find electron, proton, neutron?
Yes, sir. It's invisible to naked eye.
Exactly. Just we have to assume, yes, this is electron. No, because I'm teaching the 12th standard, now they're finding like, sir, how to understand this? I said, you have to imagine now what to do. Okay, so when can we say, yeah, zero work done? It's very easy to give me one example if zero work done.
A stable wall.
Yeah, pushing a wall.
Yeah, a rigid wall.
Yeah, or a merry-go-round. That means, in short, what we want, force and displacement should be at 90 degrees to each other. Right, so if we are moving in circular path, so force and displacement in 90 degrees. Therefore, work done is zero when we are moving in circular path. Another one, someone is holding or carrying some luggage on your head. Generally, let's say coolie. This has, excuse me, coolie. Load, right? That is also work done to be zero because force and displacement are perpendicular. Okay. Now, Manoj sir, how much Manoj sir finished from this chapter? Did he finish everything?
Oh, no, sir. Only the very basic part.
Oh.
Yeah, I didn't even teach these, sir.
No, this are like, okay, fine. Because I might teach extra or something extra because it only one or two topic extra. Do you have work energy theorem, right?
Yes, sir. It is.
Okay,
Everything is there, sir. Nothing is related.
okay, everything is there. No? Graphical method.
Yeah, the whole chapter is there. Nothing is related, sir.
Okay, then it's good. Then we can complete whole.
Yeah. In fact, actually, this extra stuff will actually be useful, sir, for your life, for future. Yeah.
Okay. No, because like whatever I have content, okay, fine, I'll give you. But while teaching something, like I'll go in some other topic and I'll give some other extra things that might happen. Okay. Let's go with example of negative. Okay. Just now we saw one friction. Apart from that, same example we can free falling object towards the earth. This is against the gravity. That will be negative, right?
Yeah. Sir, a non-accelerating truck in a uphill, sir, it will go down.
Yeah, that is also true.
Yeah. Technically, if you put down a clutch, it will go down, sir, because of gravity. So negative work.
Exactly. Or let's write that one also.
It's too lengthy, sir. It's fine for something simple.
Work done by friction.
Yeah, exactly.
And work done by gravity, against the gravity.
Yeah, against the gravity.
Work
On
done,
a steep uphill, so you'll notice it.
yes, against gravity, which is negative. This both gives negative work done. Okay. So you know how free body diagram, right?
Yeah.
Okay, cool. So this is the object, force acting, and angle between them. This. So what are the forces acting on this object? If I draw free body diagram of this one, so one will be
Gravitational force.
Gravitational force.
exactly, what is it? mg.
mg.
Yeah.
And frictional force also.
Yes, opposite force, which
Small
is
f,
opposite.
so
Yeah, frictional force. This one,
normal force.
Normal.
normal force is here, perpendicular to the surface. And one force, let's talk this force later. Let's see this force first. Force F. Now, which is making angle.
Theta.
So as usual, this is frictional force. This is weight mg. This is normal. And this is applied force. Note down in this one, right? Free body
No, sir,
diagram.
no doubt.
Okay. So as we saw previous also, like a uniformly distributed body we saw, right? Previous chapter. So in this case also, if I want to find the force and displacement for ununiform like thing, which we cannot find out. So what we'll do, if it is standard form, we can find area under graph. Force and displacement. We can say, okay, length into breadth, fine. Area under this curve or graph. It is uniformly forming here. Right? So if it is whatever object, we can just say work done is length into breadth of this object. We can find out. But if it is non-findable, like if it is not uneven, if our graph is like this, we cannot find this. It's not fixed. Somewhere it's more, somewhere it is less. So what we'll do, we'll just take a small strip and what we'll do, integrate throughout the limit. So always understand what is the use of integration and what is the meaning of integration. We are summing all the areas, force and displacement. So area, we are taking the small area f x force into small area delta x. This is delta. Okay, so if I say this is x1, this is x2. So what would be the limit of integration? Yes. What will be limit of integration? How to find limits? Do you know? Or no idea? Varun, Devanshika, Ritvik, Sainitya. Are you all there?
Yes, sir.
Acha. So how to find limits for this integration? No idea? Okay. Don't worry, I'll tell you. See, we are finding for this strip and we are varying from this point, that is x1 to x2. We are finding the area of the strip and we are varying from x1 to x2. So our limits are x1 and x2. So how to find upper limit? We are starting from lower limit to upper limit. So x1 is the lower limit, x2 is the upper limit. So work done by this force f of x x dx, limits are x1 to x2. So how we are getting this? We are finding each strip, and we are summing it. So instead of summing of f of x dx, force and displacement, to find work done 1, work done 2, work done 3. Instead of that, we are integrating directly so that we can substitute all the limits and we can find our answer, whatever limits we have. That is x1 and x2. So this force is resultant force. Force of x. And this work is total work. Do you have any doubt in this one? Guys, can you hear me? You there?
Yes, sir. Just a minute.
Okay. What about internet issue?
You can explain the limit part again.
Okay. Now see how to find limits. Like see it in generally, forget this one, integration part. Forget this one. So from where it is starting? At 0th in x-axis. I'm talking about x-axis. 0th. Where it is ending? Let's take this here 2. 0, 1, 2. From where? It's varying from 0 to 2. Displacement is varying from 0 to 2. Upside force is varying from 0 to 2. So y-axis varies from 0 to 2. Right? Force varies from 0 to 2. That is our limit. Now 2 is the limit for 0 and 2 is the limit for displacement, and 0 and 2 is this limits for force. Similar way, for for integration, we'll find limits. We are integrating for a strip. For this small strip, we found area. We will calculate this area here and will vary from this limit to this limit. We'll just take small area for this one. We took the small area and will vary from limits, which is x1 and x2. Upper limit is x2, lower limit is x1. So here I wrote upper limit and lower limit. So when we are integrating, we'll substitute values of upper limit and lower limit as upper limit minus lower limit. You know this little bit, integration? If not, no problem. While doing this numericals, because work done in work, we have everything in integration only. You'll learn it. Even we'll use some more formulas for integration. So eventually we'll learn it. Let's start with the first numerical. Oh, but still, do you have any doubt, or it's clear, or it's some more doubt?
Cleared.
Clear? Okay. This is our limit. Okay, let's take one question. First, let's start with easiest one. A block of mass 2 kg is pushed 2 meter along frictionless horizontal table by a force of 15 Newton. So what is the work done by applied force? What is work done by applied force? Second one, what is work done by normal force exerted by table? Third, what is the work done by force of gravity? Can you try this? It's very easy.
First
Standard
one is
form.
30,
First
so
one
30
is-
joules.
Yes, sir.
Yeah, very easy. Standard formulas.
Fs cos theta. I should.
Yeah.
W equals to
Fs cos
Fs.
theta.
Cos theta is 1.
Yeah. Cos theta is 0, so cos theta 1.
So force, first one is 30 joules.
Yeah.
What about second and third? Okay, for that, shall I read question again? Do you want me to read question again? A block of mass 2 kg is pushed 2 meter along a frictionless horizontal table by a constant force 15 Newton. This was the statement. So what do you think? What would be normal force? Sorry, work done by normal force and work done by gravitational force?
Normal force we should do ns. Sir.
Okay. Fine. Then
Yeah, same ns cos theta.
okay. NS cos theta. So what you'll get? 30. That's what you're saying?
Yes.
What about then third one?
19.6.
19.6.
No, I don't think so, sir.
Did you use 9.8 value? That's why.
Yeah, 9.8 value, that's fine. But I don't think so.
Okay. Mhm.
How do you do it, sir, for the normal force and force of gravity?
See, simple. Actually, there's nothing in this question. Normal force is what? Force which is exerted normally, in short, vertically. There is no vertical displacement. Therefore, work done is 0 because no vertical displacement. Right?
Yeah.
What is this one? It's just moved from here to here. So normal force and this one. That is what we need to find out. Therefore, if there is no vertical displacement,
Well, force of
therefore,
gravity is mg, right, sir?
that is mg, formula F equals to mg, fine. But here also it will be 0 because there is no downward motion or upward motion.
Yeah.
Here also force due to gravity is again this also zero, because if normal force is zero,
Yes, sir.
so this is also zero. It's not because of this one, but due to no downward motion or upward motion.
Yeah. It's just on rest. It's just on flow, sir. So yeah, no gravity.
Exactly. As no downward motion. Let's do another one.
Yes, sir. Let's do another one.
Yeah. Wait, I'm thinking of giving some competitive exam question. Okay, first try this one. Let's see how you're doing. Then I'll give you some tougher questions. This vacuum cleaner. Okay, it's easy, Malaya. So force is given as 75 Newton. Makes an angle theta as 30 degree with the horizontal. It displaced 5 meter in the direction of force. Okay, I'll read this question. A lady pulls a vacuum cleaner with a force of magnitude 75 Newton. The force makes an angle 30 degree with the horizontal. If the vacuum cleaner is displaced 5 meter in the direction of force, calculate the work done. So work done will be how much? Force into displacement into cos 30. Give me answer fast within 30 seconds. Ten seconds. 20. Come on, fast.
130 joule.
30, 375 root 3 by 2.
Are decimals? 30 seconds over. Decimals.
129.75.
Is it 129? 75 into 5 into cos
1.24.
30.
Yes, sir. I was still calculating decimals. Normally 375 root 3 by 2.
Okay. So then you can just calculate this. Next. A force is given.
It's 324.75 something, sir.
Okay, 324.75.
75 and so on.
Okay, whatever. Fine. A force is given as a constant force 6.0. I'm sorry, I. It's not J, it's I. I cap plus 4 J cap Newton. Acts on a particle, it undergoes displacement S equals to 3 I cap plus 4 J cap in meter. So find out work done. Cap, I forgot. So work done question mark. So what you'll do? Force into
Yes.
so you know vector dot product?
Yeah, we're going to dot products and not cross product, right?
Yeah.
Okay, yeah.
Dot product. Just multiply direct terms. Right?
Yes, sir. That's it. Back.
And add it. Simple. Six I plus 4J 3I plus 4j will give you 18. 6 is 18 plus 4 4 is
16.
16,
Yeah.
which is 34.
34.
34 joules. Yes, sir.
Sit dot product.
Yeah. Is everyone got same?
Yes, sir.
Yes, sir. Same.
What about these two girls, Devanshika? Is she there? Okay. Okay. Okay, let's try this. Let me draw a shape. Okay. So these are 10. These are 20 newtons. Force in Newton. This is displacement in meter or x.
X-axis is displacement. Sir.
Yeah, in meters. Exactly. So as usual, this is 10. Is minus 10. This is
Minus 20.
yeah. So find out. Okay, let me read this. Okay. The relation between force and position of the body is given along x-axis as shown in the figure. Okay. What is the work done by force in displacing body from x equals to 1 meter to x equals to 5 meters? So that means these are 1, 1, 1. 1, 2, 3, 4, and 5. That's what it means. Okay. Try this. It's very easy.
What I should find, sir? Again?
Work done.
I mean, for which ones?
X equals to 1 to x equals to 5 meter.
Okay.
It's a body. This is a graph given between what force and position in x-axis. So we have to move along x-axis, find the work done. So what you'll do?
For work done for 1 is 10, sir.
Yeah.
For 2 is 40. 3 is 60.
So
One
add
for-
all. What?
Yeah.
Who is 40?
3 is 60.
Wait,
Which
wait,
one's 3 is a down one or up one? The 2, 3.
First, second, third, fourth. This is second. This is third. This is fourth.
So I have to add both the positive 3 and negative 3.
This is fourth. 4 areas, right? 1, 2, 3, 4. So
Yeah.
what you will do generally? We'll add this, all this. We'll add 1, 2, 3, 4 work. Yeah. So find it. So first, what you said? 10.
Yeah. Second is 40.
10
Are you
into
sure?
1 plus 10, 20 into 1 minus 20 into 1 plus
1, not 2. You're multiplying by 2. See here, the difference between them is 1. Here
yeah,
we
20
also
erg, sir,
1.
answer. 20 erg.
This is also 1 and this is also 1. Yes, 20 joules.
Yeah.
This all are 1, 1, 1 only. Displacement. Okay, don't make a mistake in reading graph. This all are 1, 1, 1, 1. So 20, 10 into 1, 20 into 1, again minus 20 into 1. So this 20 and this 20 will get cancelled.
Cancel.
So we
Yeah.
have total
20.
20.
Yes.
So if I write total work done, 10 plus 20 minus 20
20
plus
plus
10,
10.
which is equals to
Yeah,
20.
that's it.
okay. So force acting on a particle moving parallel to x-axis. So force acting on a particle moving parallel to x-axis, it is given by F equals to 2x plus 3x square. Calculate the work done in displacing particle from x equals to 1 to x equals to 2. So what are 1 and 2? They are limits. So what is the equation given? F equals to 2x plus 3x square. So remember the formula, integration. This one.
Yeah.
So
work done equals to
So
integration of
two, yeah, integration.
f dx.
Yeah, two will be up and yeah.
X1 x2.
Okay, integrate this and tell me answer. They didn't give centimeter or meter, so keep it in units. Say units. We don't know whatever units are there. See what's the answer? Any progress? Varun, Devanshika, Ritwik,
Yes, sir. I did.
doing? What about
Is
you,
12
Devanshika?
joules? Is it 12?
12. No. Try again. Or maybe yes, because 6 to 3. Okay, let me check.
What is x values or some?
X value varies from 1 to 2. So lower limit is 2, upper limit is, sorry, lower limit is 1, upper limit is 2.
I did wrong. I'll do it.
Is Devanshika not there? Might be some internet issue. What about your answer, Ritvik? Ritvik,
Doing
your
so.
answer? Achha, doing. Are you facing any difficulty in this one?
Can you explain this one, sir?
Okay. Yeah. So integration of this one, limits are 1 to 2,
Yeah.
2x plus 3x square dx.
So is it 10
DX
answer?
only.
I got 10.
Okay, let me check because I think so this book answer is wrong. So let me solve this and we'll see. Okay, now integration for this one and this one. So 2x square by 2 plus 3x cube by 3. How integration of n to x to power n dx is x to power n
For
plus
n d
1 by
n plus 1.
1. So 2 is already there. So I'm bringing it x to power 1. So 1 plus 1, 2, 2 by 2. X to power 2 by 2. X to power 3 by 3. Limits are 1 to 2. Now 2, 2 will get cancelled. 3, 3 will get cancelled.
X square whole power square.
So
Square plus
x
X cube.
plus x cube. 2 and 1. Limits we will substitute.
Yes.
So 2 square plus 3, sorry,
2 cube.
2 cube minus 1
12
square
Square
minus
plus 1 cube. Yes, sir.
12 minus 2. 10, sir.
Yeah, I got it correct.
Yeah. One got it correct.
4 plus 8.
8.
12 minus 2, which is 10.
10.
Yes, sir, I got it.
10 units. That means this book answer is wrong. They wrote 17. So how did they
Oh.
got 17?
What's that sound?
Okay, they did mistake. Okay, they differentiated in one place, and one place they differentiated here. Here they integrated. No, wrong. You cannot do that. Yes. So our answer is correct. Yeah, obviously they will make mistake in book. That's why I don't follow answer of any book. I just want my solution. Let me check again. No, this is wrong only. No problem. Our answer is correct. Okay. Take this question as a homework and try to do it. Same integration part. Okay. Okay, what else? Just a minute. The body moves along the circular radius 2 meters is a work done. Okay, you can do it. So, give a try. Or else Monday we have. Okay, by the way, this Sunday I'll keep a test for system of particles. Okay.
Yes, sir.
Yes, sir.
I'll give test on system of particles. So be ready with that. On a small test, plus 4 minus 1. Negative marking. Along circumference of circle of radius r equals to 2 centimeter. No, 2 meters. What is work done by force of 15 Newton on body inclined at angle 60 degree. Shall I write full statement or you are able to understand this one? Tangent at any point. On circle. Are you able to understand or shall I write full statement? Yeah. Try this question as a homework.
Is it 15 joules?
15 Newton. Sorry, no, not correct. You have to do integration.
Okay. Not normal for me.
Tangent at any point on the circle. So shall I give you a hint? W equals to integration of f ds or f cos theta ds. So these two things we know. We don't know this one. Okay. Try this. Shall I stop sharing?
Just 1 minute.
Okay, sure. Take 2 minutes. I don't mind.
Done, sir.
Okay. Varun, done?
Yes, sir.
Okay then, bye-bye. Be ready for your Sunday test. Only 10-15 questions I'll give with negative marks.